Throughout history, human civilization has always been shaped by the elements of the periodic table. From the air we breathe to the bones in our body, from the medicines we take to the technology we use, everything is connected to chemistry. In today's video, we move one step forward from alkali metals and explore the fascinating world of alkaline earth metals, specifically magnesium, calcium, and barium. These elements may look ordinary on paper, but in reality, they are the building blocks of life, industry, and even space exploration. So, let's dive deep and uncover the secrets of these powerful elements. Magnesium is a lightweight, silvery metal that sits at the top of the alkaline earth family and combines interesting chemistry with vital biological roles. Its electron configuration, Na3s2, means it readily loses 2 electrons to form a Mg2+ ion. But because those electrons are relatively tightly held compared with heavier group 2 members, magnesium is less violently reactive with water at room temperature. Cold water produces only a slow reaction that often appears as faint fizzing and a thin white film of magnesium hydroxide, while hot water or steam reacts more vigorously to give magnesium oxide and hydrogen gas. Magnesium burns with an incredibly bright white light, a property exploited in flares, fireworks, and historical flash photography. And the burning reaction is simply Tme plus O2, 2MgO, releasing a lot of energy as visible and ultraviolet light. Chemically, magnesium forms useful compounds. Magnesium oxide, MgO, is a refractory used in furnace linings. Magnesium hydroxide, MgOH2, is the mild antacid and laxative known as milk of magnesia. Magnesium sulfate, MgSO4, Epsom salt, is used in medicine and agriculture. And magnesium chloride, MgCl2, is a common industrial salt. In metallurgy, magnesium's combination of lightweight and respectable strength makes it a prized alloying element, Al-Meg alloys, in aerospace and automotive parts, where reducing mass is crucial for fuel efficiency. Biologically, magnesium is indispensable. It sits at the heart of the chlorophyll molecule, enabling photosynthesis, and in animals it stabilizes ATP and acts as a cofactor for hundreds of enzymes. Without adequate Mg2+, many cellular processes falter, producing muscle cramps, fatigue, and metabolic issues. Safety-wise, metallic magnesium must be handled carefully. Fine magnesium powder or ribbons can ignite and burn fiercely, and such fires are not extinguishable with water. Class D or dry powder extinguishers and sand are required. For visuals in a video, imagine a bright white ribbon of light ripping through darkness. That's burning magnesium, and a soft white paste, milk of magnesia, soothing an upset stomach. Both are the same element showing very different faces. Calcium is the element most people meet in everyday life, because it forms the minerals and compounds that make up bones, teeth, chalk, and much of the Earth's crust. With electron configuration, R4s2, calcium loses 2 electrons to form Ca2+ and is more reactive than magnesium, especially with acids and with warm or cold water, Ca plus 2H2O, CaOH2 plus H2, producing lime water. In nature, calcium is overwhelmingly found as calcium carbonate, limestone, marble, shells, and as calcium sulfate, gypsum. And those minerals are the raw materials for cement, plaster, and construction materials. Quicklime, CaO, produced by heating limestone, is a pillar of building and steelmaking industries. Calcium hydroxide, slaked lime, dissolves slightly in water to make lime water, which turns cloudy in the presence of CO2 because calcium carbonate precipitates. This classic lime water test is a great classroom demo of acid-base chemistry. Biologically, Ca2+ is central. Bones and teeth store calcium as hydroxyapatite, a calcium phosphate mineral, which gives structural strength, while soluble Ca2+ ions act as a universal cellular signal. They trigger muscle contraction, regulate neurotransmitter release in nerves, and are essential for blood clotting cascades. Calcium compounds are also widely used in agriculture, lime to adjust soil pH, in de-icing, calcium chloride, and in food fortification. In flame tests, calcium gives a brick red or orange-red color, useful for quick identification. Pure calcium. Metal is reactive and must be stored under inert conditions. Handled incorrectly, it will react with water to release hydrogen and heat, so labs and industry use appropriate safeguards. When teaching this material, visuals that connect classroom chemistry to real life, a chalk stick, KCO3, a cement mixer, CaOKOH2, an X-ray of bones, hydroxyapatite, help learners see how calcium molecules build the world around us. Barium, the heaviest of the three you asked about, is a dense, silvery alkaline earth metal that shows how group trends intensify downwards. With electron configuration Xc6s2, barium loses 2 electrons more easily than magnesium or calcium, and therefore reacts more vigorously with water to give barium hydroxide and hydrogen, Ba plus 2H2O, BaOH2 plus H2, producing strongly. Alkaline solutions. Unlike magnesium and calcium, barium's most important practical presence is as a compound rather than as the free metal. Because many soluble barium salts are highly toxic, Ba2+ interferes with potassium channels in the body and can cause muscle weakness, breathing difficulties, and cardiac problems, so you rarely see the metal itself in daily life. The striking exception is barium sulfate, barite, BaSO4, which is extremely insoluble. Because it does not dissolve, it is safe for use as a radiographic contrast agent, the barium meal or barium swallow, that outlines the digestive tract on X-rays. Industrially, barite is mined and used as a high-density weighting agent in drilling fluids for oil and gas wells. Barium carbonate and barium nitrate find specialized uses in ceramics, glass, to raise refractive index, and pyrotechnics, giving green colors, while barium titanate, BaTiO3, is a valuable ferroelectric ceramic used in capacitors and piezoelectric devices. In flame tests, barium compounds produce a distinctive green color, which pyrotechnicians exploit to create green fireworks. Because soluble barium compounds are hazardous, handling and disposal rules are strict. Workers use protective equipment and medical exposure is treated promptly. For dramatic classroom or video visuals, contrast the bright green fireworks produced by a barium compound with the clinical, opaque white slurry of barium sulfate used safely in medical imaging. Two very different outcomes because of the compound's chemistry and solubility. Taken together, these 3 alkaline earth elements illustrate how atomic structure governs behavior. Each has 2 valence electrons and commonly forms +2 cations. But as you move down the group, the atoms get larger, the ionization energy falls, reactivity with water and acids increases, and the hydroxides grow more soluble and more strongly basic. MaOH2 is only sparingly soluble and is a milder base. KOH2 is somewhat soluble and is used in construction and water treatment. BaOH2 is more soluble and strongly alkaline. They also show a beautiful link between pure chemistry and everyday life. Magnesium powers photosynthesis and stabilizes our cellular energy currency. Calcium literally frames the bodies of animals and regulates heartbeat and muscle movement. And barium's compounds help us image internal organs and engineer materials for electronics and drilling. But they also teach caution, because chemical form and solubility determine whether an element is helpful or harmful. If you'd like, I can convert these extended explanations into a single flowing script suited to an 11 Labs voiceover with visual cues, flame test clips, and suggested images for each segment.